Welcome back to another video, and this video we are going to talk about current concurrency in Rust. Now, concurrency in Rust allows multiple tasks to run simultaneously, leveraging the power of the modern multi-core processors efficiently and safely. So, Rust ownership types and borrowing rules lend themselves well to writing safe concurrent code, preventing data races and ensuring thread safety without needing a garbage collector. That's what we saw before. Now, some of the key concepts in Rust concurrency includes threads, the most fundamental unit of concurrency. Rust provides a way to run code on different threads. There's also message passing, where concurrency often involves multiple threads or actors communicating with each other. Now, Rust encourages a message passing concurrency model using such channels, and we'll see that in a little while. Also, the shared state. Rust also supports shared state concurrency, but it enforces strict rules to ensure the safety. Last is the sync and send traits. These marker traits allow Rust to ensure that your types are safe to use in concurrent context. Now let's look at how to use threads. So first, creating the threads. So you can use the thread colon span function to create a new thread and run code in it. And this requires passing a closure to thread spawn that contains the code you want to run in the new thread. Let's look at an example here. So what I'm going to do is I'm going to first use the import, make sure that thread is in the context, and then another module that I need is the time module, so I can put it to sleep for a little while. So I need these two modules. Once I have that, next I'll probably inside here, let's say, let me get rid of everything. I need thing in here. Make sure this is okay. So then I'm gonna say thread spawn. This is what I was talking about. So I create a thread spawn, and inside that give a condition and say here for I in a range of 1 to, let's say, 10, so it's actually 1 to 9, print ln, and inside this I'm going to say, let's say, high number, particular number that I'm going from the spawned thread, and inside here I'm going to pass the I number that we have here. And then once this is done, I'm going to make it sleep for a smaller duration. So I'm going to just say duration from I LLIS milliseconds of 1. That's what I'm going to do. I am going to do one more outside the thread. In this case, I'm going to say for I in. So this is outside, so this will not have any problem with the other I because the scope is different. Println high number from the, so whatever I do here is the main thread, so I'll say from the main threads, and whereas whatever since I'm creating a separate thread here and running this, it's a separate thread that's running concurrently. So I'm going to say I here, and I'm going to do the same thing here. So this, what it does is just puts the main thread to sleep in this case, and it will sleep for a second. I'll run this application, so you'll see. So high 1 from main thread, spawn thread, main thread, spawn thread. So it's running simultaneously at the same time. If you see in this case, it ran up till 5 because the main thread is done after this. So that's why nothing happens. Since the main thread is over, the function is over. So there's not this thread, even though it's running in the background, will be killed after that. So you have to be careful when you spawn threads, and if your main thread is not running, then the side threads will not run. It will close the application. Now, waiting for threads to finish, you can use the join method on the handle returned by thread spawn to wait for the thread to finish. That's another way of doing it, where you can just say, so for example, I can go here and I can say let handle equal to, and to make sure it runs, to do is join dot unwrap. So this is what will make sure that the thread returned will probably complete, and you'll wait for it to run. Let's look at an example of that. So if you see in this case, it waits for it to completely finish and then it runs this code after that. Next thing that we want to look at is message passing, which is Rust standard library provides an implementation of channels for message passing. That's what I said, like, we'll use channels. Now channels allow you to send messages between threads. So let's get rid of this, and what we need is, so we want multiple producer and single consumer class. So what I'm going to do is I'm going to say use std standard sync multiple producer single consumer. That's the library that we want, that's the module that we want. This I don't need the time one anymore. Inside my function I'm going to say let tx comma rx transmitter and receiver mpsc, create a new channel. So this is how you can create a channel. Once you create this channel, you can spawn a thread. How do you spawn a thread? Spawn a thread, I can say move or run this, and inside this I'm going to say let message equal to string. So the message that I want to send, so I want to send a message hi, and I say transmitter dot send msg and unwrap that. So that's my transmitter sending the message. Now let's see if the receiver, which is the main thread, received the message. Received equal to rx dot receive, and let's say unwrap. Here I think I forgot the dot, and then I can go ahead and say println. Oop, I think I got that. What did I receive? Let's see, got comma received. So I'm printing that out. So let's check how this message passing is working. And if you see here, it's saying could not compile Hero Rust due to one previous error. Let's clear this, and okay, so I forgot. So I have my MPSC. Where did I forget the? Okay, here. And there you go, got hi. So it sends hi, and this thread that was spawned, it sends hi and it's received by. So you can send messages between threads. So if you want to a particular thread to do something, and then once it's done, send a message to the main thread, you can have this channel created and send these messages. Next is the shared state concurrency. Now Rust ensures safe shared state concurrency using its ownership and type system. The mutex and arg types are particularly useful. Now let's see how to use the mutex. Mutex allows only one thread to access some data at a given time. So I have my sync. What I need is I need mutex, and I'll also use arg right now. I have my thread. Get rid of this here. Let's create a counter in the start. I'm gonna initiate a new arc, and inside that I use mutex new at 0. So that's how you can create an arc with an element mutex inside this. I'm gonna create a mutable handle with vectors inside this. You remember we can create vectors using this macro. Now for underscore, which means I don't want to create a parameter or a variable in this case, so I can just give underscore, and I can say let counter equal to arc clone and pass the address of the counter to it, and I can say handle equal to thread spawn move, something we saw before. We create a spawn thread, and inside this thread I'm going to create a mutable number, which is my counter dot. I'm going to lock that so nobody else can use it. Unwrap it and then increment the number by 1. Now once I do that, okay, do not forget the semicolons. Handles dot push this handle into there. So whatever I created, push that handle into. So keeps on adding it inside the handles, and I have 9 or 10 0 to 9 handles inside there. Now to make sure that they run, what I'm going to do is handle in handles. If you remember this, we did make sure that they all run. Join is what we use, and of course unwrap. Now we can print this by saying result is counter dot lock. So I lock that value, and I'm gonna say unwrap standards. And now if I run this particular application, so the problem here, I see what the problem is. I missed a semicolon here, so I'm going to go ahead and run this again. And if you see, result is 10, because it probably made sure that it got the counter incremented, and every time it increments, I have the last number, which is 10, which is the result out here. So next is sync and send traits. Now the compiler automatically adds the send trait to types that are safe to send to another thread, and sync traits to types that are safe to be referred from multiple threads. Now in this case, send, it indicates that ownership of the type implementing send can be transferred between threads, whereas sync indicates that it is safe for the type implementing sync to be referenced from multiple threads. Now from what this particular video, what we learned is rust-concurrency model emphasizes safety and data race prevention. It provides powerful primitives like threads, message passing through channels, and shared state concurrency with mutex and arg, all while leveraging its ownership and type system to compile time checks for thread safety. Now this approach allows you to write efficient concurrent code with confidence, reducing the risk of common concurrency pitfalls which you face in other programming language. So that's how threads or concurrency works in Rust. So if you have any questions, please leave a comment and I'll get back to you.